IXL Section BB.6, solve a quadratic equation using square roots. Alright, this IXL is pretty easy, and this type of stuff definitely comes out on the Algebra 1 EOC the same way that you're seeing it here with fill in the blanks. Alright, so, and this is so simple to answer. Alright, so in all of these, you're going to be solving these quadratic equations. In other words, solving, like for example, here's my first example. You're solving for j. Okay, the first example says solve for j squared equals 25. So you got to find out, okay, so what is j? All right, it's very simple. It's a simple process for most of these. J is the square root of 25. And you got to realize that the square root of 25 is both positive 5 as well as negative 5. All right, that's what that means, that positive and that negative sign. All right, because negative 5 times negative 5 equals positive 25, just like positive 5 times positive 5 equals 25. All right, so in your answers choices, you would put, one of them would be positive 5 and the other one put negative 5, and that's it. It's that simple. Okay, so right here, y squared equals 64. All right, so that means that y would equal the square root of 64, which means that y equals positive and negative 8. Everybody should know their timetables by now. 8 times 8 is 64. So y equals 8 and y equals negative 8. It doesn't matter which one you put in which box. It'll still be correct. Okay, the next one, solve for h. H squared equals 81. That means that h equals the square root of 81. So h equals positive and negative 9. Okay, so h equals positive 9 and h equals negative 9. And the last one on this slide, p squared equals 121. That means that p equals the square root of 121. So p equals positive and negative 11. So p equals 11 and p equals negative 11. That is super simple. All right, let's go on to some more examples. All right. Okay, here we're going to have the same exact concept. We just got to do a little bit of work at the beginning to get the variable by itself. Okay, so in our first example, it says we got to solve for k. K squared minus 36 equals 0. Let me write it over here. K squared minus 36 equals 0. So what you have to do is just first move the 36 to the right by doing the opposite of subtracting. I'm sorry, by doing the opposite of by doing the opposite of subtracting by 36, which would be adding both sides by 36. So that'll make k squared equal to 36. What's the square root of 36? All right, k will equal the square root of 36. So k equals positive and negative 6. So k equals 6 and k equals negative 6. Whoops. All right, example 2 here. K squared plus 63 equals 88. All right, so again, first move the 63 to the right by subtracting from both sides. So x squared equals 88 minus 63 will be 25. So x is going to equal the square root of 25. So x is going to equal positive and negative 5. So x equals 5 and x equals negative 5. Very simple. And the last example here, v squared plus 37 equals 38. I move 37 to the right by subtracting from both sides. So v squared equals positive 1. So v equals the square root of 1. So v equals positive and negative 1 because the square root of 1 is 1 as well as negative 1. So v equals positive 1 and v equals negative 1. Okay, moving on. All right, same thing. Again, I first got to get the variable isolated on one side of the equation. So for our first example, we have 100 n to the second power minus 4 equals 0. First move the 4 to the right by adding both sides by 4. Okay, so now we got 100 n to the second power equals 4. Now move the 100 to the right and divide. Okay, now this one's easy, but you should pay attention to it because this is the first one with fractions in this little presentation. All right, but it's very simple. All right, so I'm going to follow the same step. Just leave it like that, like a fraction. Don't divide it any further, okay? Hopefully you're paying attention. All right, everybody should be paying attention to this one. Leave it like that as a fraction. I guess you could simplify it, but nah, I wouldn't simplify it. Leave it like that, actually. If you simplify it, you're actually going to make it more difficult. All right, so n is going to equal the square root of 4 over 100. So now just get the square root of each of these numbers. So n is going to equal positive and negative 2 over 10. All right. You could also write positive and negative 1 over 5. Let me see. Actually, in this case, my bad. Okay, we got to write our answers in simplest form. Sorry, I was thinking for a second. All right, so now let's simplify it. All right, so n would equal positive and negative. When you simplify 2 over 10, you get 1 over 5. All right, so n equals positive 1 over 5. And by the way, you could just write it like that on the on IXL, as well as negative 1 over 5. Like that. That's what I meant to write. All right. So again, it's easier. It's best if you don't simplify it until the very end. It's easier that way. All right, let's look at the second example. In the second example, again, let's get h to the second power. Let's get the variable by itself, okay? So in the second example, we got 9h to the second power minus 93 equals negative 57. All right, so let's move 93 to the right by adding. Okay, so I'm going to have 9h squared equals, hold on, 93 minus 57 is going to be 36. All right, so h squared equals, move the 9 and put it below the 36 to divide. 36 divided by 9. So h squared equals, 36 divided by 9 is 4. So h equals the square root of 4. So h equals positive and negative 2. Positive 2 and negative 2. All right. Then the last one, 12m to the second power equals 75. Divide, or move the 12 and put it beneath the 75. Okay, now if I simplify by dividing the top and the bottom by 3, I'm going to get 25 over 4. And now let's get the square root of 25 over 4. I'm running out of space, but the square root of 25 over 4 is going to be positive and negative 5 over 2. All right, so I'm going to put in my answer positive 5 over 2 as well as negative 5 over 2. Oh, whoa, I'm sorry, I wrote that in the wrong one. It's this one down here. Forgot which one I was doing. Positive 5 over 2 and negative 5 over 2. All right. Okay, now we have 2 more slides, and these questions are easy. I want to go over how you answer them, all right? The questions are asking you how many real solutions does the equation have? So first of all, let me explain what that means. Okay, if solving this quadratic equation gives you 2 answers, then that would mean that you have 2 real solutions. If solving it gives you 1 answer, that means you have 1 real solution. There's only one situation where you have no real solution, and that's when you have the square root of a negative number, which I have one example coming up. When I get to it, I'll explain it. Let me do a couple examples so you can see what I mean, all right? So in this first example, all right, it says q squared plus 63 equals 63. So again, my first step is to get q isolated. So let's move 63 to the right by subtracting. So now my equation says q squared equals 0. So that means that q equals the square root of 0, and the square root of 0 is just 0. That's just one answer. So this equation has 1 real solution. That would be the answer. It has 1 real solution. All right, that's very simple. All right, let's look at this example right here. H squared is already isolated. All right, so h equals the square root of 62. Now look, you could just stop right there and not continue simplifying this, all right? You know what? Let me simplify it real quick just to show you what I mean. But you could stop right there. I'll explain why. It's going to have two real solutions. The two real solutions are going to be positive as well as negative, the square root of 62. If I simplify this any further, let me check if I can. Actually, you cannot. You can't simplify this any further. All right, so the two solutions would be h equals positive square root of 62 and h equals negative square root of 62. Because if I multiply negative square root of 62 times negative square root of 62, notice the negative sign is outside the radical sign. All right, if I multiply those two together, I'll get positive 62. All right, so this has two real solutions. These are the two real solutions. All right. Okay, over here, how many real solutions does this equation have? So if I'm going to start by moving 95 to the right. So z squared equals 95. So this one is just like this one, right? Z is going to equal the square root of 95. Honestly, it doesn't, if I could simplify this further, it doesn't really make a difference. It's going to have two real, it doesn't make a difference for this question. The answer is going to have two real solutions. One of them is going to be positive square root of 95, and the other one is going to be negative square root of 95. All right, those are the two real solutions. Okay, on this one, when you move the 55 to the right, you're going to have f squared equals 0. So that means that f equals the square root of 0. So there's only one real solution, which is f equals 0. Basically, when the variable to the second power equals 0, there's only going to be one real solution. When it equals a positive number, there's going to be two real solutions. And I'll show you the one with no real solution coming up as soon as I get to it. It's going to be this one right here. All right, so as I said, when the variable to the second power equals 0, there's only going to be one real solution. All right, because the answer to this one is that y equals the square root of 0, and the square root of 0 is 0. There's only one answer. All right, same thing with this one. It's going to be t squared equals 0. So t equals the square root of 0, which is 0. There's only one answer, one real solution. Okay, for this example down here, we have n squared minus 27 equals 0. So get the variable by itself by moving 27 to the right. So n squared is going to equal 27. Okay, now n is going to equal the square root of 27. And we could stop there. It's not necessary to continue to simplify this. Okay, the two real solutions are n equals the square root of 27 as well as n equals negative square root of 27. If you break this down further, it would be 3 square root of 3 and negative 3 square root of 3. Okay, those are the two real solutions. Okay, and then this is the last example. This is the only one that I got when I did the IXL that has no real solution. Please pay attention to this example because it's simple. All right, so this example, and it'll help you understand when it's no real solution. So for this one, we got j squared plus 58 equals negative 6, okay? So to get j squared by itself, I move 58 to the right by subtracting. So j squared equals negative 64. All right, now here's the issue. All right, to get rid of this exponent, I would have to get the square root of both sides. You cannot get the square root of a negative number. The only way to do that is by using, I'm not making this up, by using what's called imaginary numbers. That's an actual thing in math, which you use in Algebra 2, imaginary numbers. I know some of you are like, what do they look like? Imaginary numbers, it's just basically the same thing as your regular numbers, but they add the letter I. Okay, the letter I, which stands for something, okay? But basically, you cannot get the square root of a negative number. I mean, think about it. If the square root means What number times the same number will give you the number that's written here? And if you multiply a negative times a negative, you get a positive. And if you multiply a positive times a positive, you also get a positive. So it makes it impossible to get a negative number when you're multiplying the same number times the same number. So how are you going to get the square root of a negative number? That's why whenever you're getting the square root of a negative number, it has no real solution, like no real number. The answer is not going to be a real number. All right? So whenever you encounter this situation on this IXL, the answer is no real solution. Whenever you try to get the square root of a negative number. All right, guys, that's it for BB6.